Welcome. Last time we talked about the power rule for whole number exponents. But as I mentioned while describing the power rule, it works for any exponent, even fractional exponents, negative exponents, or even irrational exponents for that matter. Which means I can differentiate more than just polynomials, as you can as well, as long as you know how to write certain types of expressions in terms of exponents, possibly fractional or negative. So remember from algebra that nth root is same as power 1 over n, and x power negative n is same as reciprocal of x power n. So to differentiate something like the function here, 5x power 4 minus cube root of x power 4 minus 5 over x plus 4 over square root of x power 5, if I know how to write it in terms of just exponents in general, I already know how to differentiate these. Because 5x power 4 is already in convenient form, so we'll leave it alone. Cube root means power 1/3, and if you have repeated powers, you multiply the exponents. So cube root of x power 4 is same as x to the power 4/3. Then I have minus 5 times 1 over x. Reciprocals correspond to negative powers. So 1 over x is x to the power negative 1. Finally, I have plus 4 times 1 over square root of x power 5. So I need to combine the two things I did for the last two terms. Square root is the second root. So square root of x power 5 is same as x to the power 5 over 2. Its reciprocal is x to the power negative 5 over 2. Now remember, in power rule you always subtract 1 from the exponent. So if you have fractional or negative exponents, I recommend that you write down two steps. One where you just subtract 1, second where you do the arithmetic. The reason for this is that when you have a positive exponent, when you subtract 1, the absolute value decreases. But if you subtract 1 from a negative number, the absolute value increases. Negative 1 minus 1 is negative 2. And just to remind yourself of this and not to be in a hurry and make mistakes is why I recommend that you do this in two steps. So in the first step, I'm going to just apply the power rule. Derivative of x power 4 is 4 times x to the power 3. Derivative of negative x to the 4/3 is negative 4/3 times x to the power 4/3 minus 1. And I'm going to do this for the next two terms. So I get negative 5 times negative 1 x to the power negative 1 minus 1. And then plus 4 times negative 5 halves times x to the power negative 5 halves minus 1. 5 times 4 x cubed is 20x cubed. Then I have minus 4/3 x to the power 4/3 minus 1. 4/3 minus 1 is 4/3 minus 3/3 or 1/3. So I get negative 4/3 x to the power 1/3. Then I have negative 5 times negative 1, which makes it positive 5. X to the power negative 1 minus 1. Negative 1 minus 1 is negative 2. Finally, I have 4 times negative 5 halves, that's negative 10. And then x to the power negative 5 halves minus 1, that's negative 5 halves minus 2 halves, which is negative 7 halves. Of course, you can write this in terms of fractions and radicals, but generally in calculus, fractional and negative exponents are preferable, so we'll usually leave the answer in this form. This concludes the illustration of the power rule. Next time I will say something about the proof of the power.